What, you want more volume to solid revolution with disk method? But of course you do. And in this video, we're going to go over how to find the volume of a solid revolution when we actually revolve a region about the y-axis and about a vertical line. It's very cool. Let's do this. Find the volume of the solid made by revolving the following bounded region about the y-axis. So this is the direction we're going now. Very cool. So y equals x squared. That's this. I'm going to expand onto the second quadrant, except I've got x equals 0. So that's this right here. And then y equals 9. That's this right there. So I draw in that region, y equals 9, x equals 0, y equals x squared. That's the bounded region. We're revolving it about the y-axis. Let's see what that looks like now. So you'd mirror it. If you just want to kind of give yourself a quick sketch like this, you'd end up with a bowl, but it's a solid bowl because notice that the region, which is this right here, is flush against the axis we're rotating about. Now, I mentioned in the first video in this disk method series that you always need to make sure that your disks are perpendicular, your radius as well, perpendicular to the axis about which you're rotating. So this would be the radius now. And so what happens with our disk? Well, we're going to end up having a disk that looks something like this. Okay, all right, so we got a disk like that. So let me kind of bring that out here. It's not necessarily going to be a rectangle that looks like that. Let me make it a little bit better. You're going to have something like this. Beautiful disk. So that's what we're going to end up having. So instead of having dx, you now have dy. Why is it dy? Because the thickness is really short, going up and down now, and you're stacking these disks from bottom up to the top. So just make sure that you recognize, since you have dy, and it's with respect to y, that all your functions now need to be with respect to y. So we're actually going to have to solve x in terms of y. So I'd square root both sides, and I'd get x equals root y. It's only the positive root of y because I'm just dealing with the positive side, right, of x. And so now we've got that. Well, let's look at our radius. It's this point minus that point. Like we did in area, it's right minus left. To keep things positive, you need a positive radius. So r is going to be equal to the square root of y, that's here, to that point, which all along here is going to be the point x equals 0, or the curve x equals 0. And there's your radius. Just like before, we're going to have the antiderivative from a to b of pi, radius squared, but it's dy now, right? And that still gives you the volume, just so your thickness is vertical. So now we get pi times the integral. A is 0, because that's where we begin, and we rise it all the way up to 9. That's y equals 9. That's our lid, if you will. So that's up to 9. R squared would be a root y squared times dy. And now we're done. That's the concept. That's what I'd have you get to, and now you're in good shape. Let's just integrate. It's not so bad. Root y squared is y, integrated from 0 to 9, dy. And integrating that, we'll get pi times y squared all over 2, evaluated from 0 to 9. And then we just plug in everything. So 9 plugged in and squared is 81 pi all over 2, minus 0 plugged in there is 0. And your final answer is 81 pi over 2, which, if you remember from a previous video, is the same volume we got when we revolved root x about the x-axis from 0 to 9. Which makes sense. There's some symmetry there. Pretty cool. Alrighty then, on to the last problem, the second problem in this video. So this one, we're going to revolve about the line x equals 9. So what happens when we revolve about a line other than the y-axis? What happens is we have some fun. So this says, find the volume of the solid made by revolving the following bounded region about the line x equals 9. So I've got root x, bam, x equals 9, there it is, and y equals 0. I'm going to draw that in a different color so we can see that, bounded below. So here's our region, but we're revolving it about the line x equals 9. That's a vertical line. So that's our axis of rotation. As always, we've got to be mindful of the fact that we need to draw a radius perpendicular to what we're rotating about. That's how a radius works. It's always perpendicular to the center, right? Or I should say perpendicular to the axis we're rotating about, not perpendicular to the center. So we've got that going on right there. Now, this one's what's a little bit challenging. First, you got to recognize that since it's flat right to left, we need to change things in terms of y. I'll remind you, it's because you're given a disk like so. And so this is dy. And your radius is going to be this distance right here. So that's r. Now we need to keep things positive. So it's got to be that minus this. But not so fast. This is in terms of x. We need it in terms of y because we're integrating with respect to y. So I square both sides and I get x. So now this is y squared. That is x equals 9. To get a positive radius, you would take the rightmost part minus the leftmost part. So your radius is going to be 9 minus y squared. That's it. That's the big concept. We rotate it, and what we end up with is a volume. And here's how to find that volume. It's going to be from 0 to, we got to figure out what that y value is. It's that point where x equals 9 and root x intersect. So I literally just plug in 9 into the square root, and that gives me, well, y equals 3. So that tells me that this is the point 9 comma 3, and so 3 is that upper y value that we're going to go to. Sweet. It's going to be r squared. So that's 9 minus y squared is the radius, squared dy. Again, I'm looking at that saying it's r squared dy. Now all that's left to do is integrate. That's it. So again, make sure that you do right minus left and keep things positive. Very important. And it is a disk because the region is flush against the axis we're rotating. So this is going to be pi times the integral from 0 to 3. We square that out, it's foiling, so be careful. That'd be y squared minus 18y squared. Right? That's because I'm doing 9 minus y squared times 9 minus y squared. And I notice I made a little blunder right there. That should be y to the 4th. Because y to the 4th, y to the 2nd times y to the 2nd is y to the 4th. Minus 18y squared, that's here. And then that's going to be plus 81. All right, let's get integrating. So from here we integrate, we get pi times. Well, we're going to get y to the 5th over 5 from the y to the 4th. This is going to be minus 6y cubed, or y cubed over 3 times negative 18. And then that'll just be straight up plus 81y. Now there's good news and bad news. The good news is we got a 0 down there. The bad news is we got a 3. It's going to be massive. So I've got pi times, just factoring that pi out. 3 goes in here. 3 to the 5th power is 243. Ugh. Minus 6 times a y cubed. 3 cubed is 27 times 6 is 162. All right, that's a pretty gnarly number right there, right? 162. But it's doable. And then plus 81 times 3 is actually going to be also 243. Oh, dear goodness gracious. Let's combine these terms here. 243 minus 162. I believe that's going to be 81. So you got pi times 243 fifths plus 81. This is where the bulk of the work is, actually, is with fractions. And that's going to be the same as pi times 243 over 5 plus, we got to multiply 81 by 5 over 5. So that's going to be 405 fifths. Oh. And that's going to end up simplifying to 248 fifths. Oh, sorry, 648 fifths. 648 fifths pi, or 648 pi over 5. So don't get like freaked out by all this extra simplifying here. Okay, you can use a calculator if your teacher or professor lets you, and if he or she does not, just take your time. It's just basic plugging in of numbers, right? That's not bad. This is what you got to practice getting to. And for now, we're done with that practice. I'll see you in the next video. We're going to go over what happens when the region is not flush against the axis. We get holes, washers. Fun. Peace.